Today we are going to talk about proportions. This should be a review, so it should be a pretty easy day. Our learning target is that you can solve problems involving proportional relationships and that you can convert between measurement systems using proportions and unit rates. So our vocabulary is a proportion is an equation that states that two ratios are equal. So here we have a proportion. I'm going to rewrite over here to work out of. 2/3, or 2/3, rather, is equal to 6/x. So these two ratios are saying that they are equal. So to determine that, we are going to, but because of that, I should say, we can find out what x is by cross multiplying. So I highlighted my diagonal one way, and here is my diagonal the other way. And so I write down my yellow numbers. I like to keep x on the left, otherwise it wouldn't matter which side that's on. So 2 times x, and I'm going to bring down my equal sign, equals my green diagonal, which is 3 times 6. Okay, so now I can just solve. So 2 times x is 2x equals 3 times 6, which is 18. So now this is a one-step equation. 2 times x means multiplication. Therefore, the inverse operation would be to divide by 2. And x equals 18 divided by 2, because this means division, fraction notation as division. 18 divided by 2 is 9. Okay, so now we have another ratio of 7/12 or 7/2 equals an equivalent ratio of x/84. So again, we would circle our diagonals. So you can circle both, or you can circle one and say, these are my yellow numbers, 12 times x, and bring down your equal sign right here. And then go for it and just say that these are my uncircled numbers, which is 7 times 84, and then solve from there. So go ahead and press pause, solve, and press play when you have finished. Okay, you should have gotten x equals 49. 7 times 84 is 588, and then we divide each side by 12, solving our one-step equation. Here, Anna made 12 bracelets in 3 hours. How many can she make in 15 hours? So here it appears that we're talking about bracelets and hours. So unlike a unit rate, it doesn't matter which one goes on the bottom, because we're not talking about per one. We're just talking about bracelets and hours. So here Anna made 12 bracelets in 3 hours. According to my word ratio, I have bracelets on top and hours on bottom. And it's asking, well, what about 15 hours? So I'm going to check back with my word ratio and see that hours goes on bottom, therefore 15 goes on bottom. I don't know how many bracelets she can make in 15 hours, so that's where my x comes from. So then now I'm just ready to solve by highlighting my diagonals or circling my diagonals and writing them down. So that's 3 times x. Remember, we bring down our equal sign. And then we have our other diagonal, 12 times 15. That's probably hard to see. Okay, and then we can solve like normal. 3 times x is just 3x, and 12 times 15 is 180. Okay, so now our inverse operation of multiplication is division. So we divide, and x equals 60. What does it mean for x to be 60 in this word problem? It means that Anna can make 60 bracelets in 15 hours. So using cross multiplication to verify if two rates are proportional. So here we can use cross multiplication to see if two ratios are proportional. If the numbers are equal, it is proportional. And if they're not equal, it is non-proportional. I like to throw in there that when looking at a graph also, the line passes through the origin. And we'll talk about that more in the future. All right, so I'm going to rewrite my problem. First ratio is 2/3, and second ratio is 9/12. Okay, so this is just about cross multiplication. So if I cross multiply 9 times 3 equals 27, and 12 times 2 equals 24. Okay, so those numbers are not equal, so I need to put that not equal sign, and then therefore it is non-proportional. And I'm going to box that because that is my official answer. So I want you to go ahead and try number 5 and press play when you have finished. You should have gotten that each diagonal is 108, therefore they are proportional. Our last problem, we're going to convert within measurement. So it says Mrs. Hutton is 5 feet tall and 5 feet and 2 inches tall, and there are 254 centimeters in 1 inch. What is Mrs. Hutton's height in centimeters? So it wants to know centimeters, and the first thing that it gave us was feet and inches. And then it tells us that centimeters to inches. So that means that I need to take my feet to inches, then my inches to centimeters. So feet to inches, and once that's all finished, inches to centimeters, just so I know what I'm doing and where I'm at. So here it tells me that we have feet to inches, so I know that there is, per 1 foot, there are 12 inches. Okay, and in this case, we have 5 feet, therefore we need to find out how many inches that is. So if I were to do my cross multiplication here, 1 times x is just x. And then I have my other diagonal of 12 times 5, and we know that 12 times 5 is 60. Therefore, 5 feet equals 60 inches, but she's not just 5 feet. She's 5 feet and 2 inches, so she is a total of 62 inches tall. Okay, but then we're not finished because it tells us that we need to go to centimeters. So over here, it tells us that we need inches into centimeters. So per 1 inch, there are 2.54 centimeters according to our problem right here. And we need to know, well, if we have 62 inches, how many total centimeters is that? Therefore, that is our x. So again, we cross multiply. Okay, we have our 1 times x, which is just x, because 1 times x is x. And then we have our 2.54 times 62. Okay, so when you multiply that, you get 157.48. What does it mean for x to be 157.48? It means that Mrs. Hutton is 157.48 centimeters tall. Make sure you write down any questions that you may have so that you can ask in class.